So we're now on to part 2 of similar triangles. Today's goal, to understand the relationship between the areas of similar triangles and their side lengths. So one thing we'll just make note of here, so we don't forget. Remember that the formula for the area of a triangle is base times height divided by 2. That may come up in some of the questions you run into in this section. So if we have triangle ABC similar to triangle DEF, here's what is true. So area of triangle ABC over the area of triangle DEF. So that ratio is equal to AB over DE. It's also equal to AC over DF. It's also equal to BC over EF. Now, we know that these ratios are all equal to each other, the side lengths, but actually the relationship with the area is different, because if we're talking about how it relates to the ratio of the areas, then these sides are squared in this ratio. Okay, so that's what's the deal here. So if we were going to write that in words, we would say the ratio of the areas is equal to the ratio of the squares of the corresponding sides. Okay, so that's quite a mouthful there, but that is the relationship that exists when we're talking about the area of similar triangles. So we'll go through some examples here, and you'll see how we use this this rule. So in this one, we've got a small triangle, ABE, and we've got a big triangle, ACD. First thing we have to do is prove that the triangles are similar. So in triangle CAD and triangle BAE, sometimes it's helpful to state the triangles you're working with. Here's what we know. Angle C equals angle B. And so because we've got parallel lines here, we have an F pattern here. So those two angles are going to be equal to each other. So I'm going to put PLT, parallel line theorem, and then I'll put an F for the F pattern. The same thing actually happens on the other side here. So the angle at D is equal to the angle at E for that same reason. And then this isn't a big shocker. Angle A is equal to angle A. So this angle at the top is part of both of those triangles. So angle A equals angle A because that's the same angle. So we say, therefore, triangle CDA is similar to triangle BEA, and our reason is angle, angle, angle. Now that we've done part A, now we're going to look at part B. So in part B, if triangle ABE has an area of 45, determine the area of ACD. So we're comparing the area of ABE with the area of ACD. So that means that we need to choose corresponding sides in those two triangles. So I'm going to use AB and AC as my two sides here. And it really doesn't matter what you use, except in this case, those are the sides that I know. I know AB is 4. I know AC is going to be 9 and 4 altogether. So you really need to look at your triangles to see what information you have. And don't forget that those are squared. So if I plug in what I know here, they gave me the area of ABE was 45. So I have 45 on the top here. I don't know the area of ACD. That's what I'm trying to find. AB is 4, so this is going to be 4 squared. And AC, so A all the way down to C is 9 and 4. That's 13 altogether. So that's going to look like that. So if I want to figure out the area of ACD, I am going to cross multiply the two numbers that I can, and then divide by the other number. So this is going to be 45 times 13 squared is 169, divided by 4 squared is 16. So when I do that calculation, the area of ACD is 475, and that's going to be meters squared. So there's our answer. So we would say, therefore, the area of triangle ACD is 475 meters squared. Okay, and there's our answer to that. And the other example we're going to look at here, given the following diagram, so in this case we're told that those two triangles are similar. If the area of triangle ABC is 135, determine the area of ADE. So I'm going to set up that ratio to begin with for A here. So area of ABC and the area of ADE. And then I need to know sides that I can corresponding sides that I know the length of. So I have the same situation here that I had going up the side in the last triangle. So in this one, I actually know the length of AE, and I know the length of AC. So AC is the whole side, so that's going to be 9 squared on the top. Actually, I'll write the letters in there first. So I'm going to use AC, so it's going to be AC squared. And then on the bottom, it's going to be AE squared. So it is helpful to write that down first so you don't mix things up. We know the area of triangle ABC is 135. We're trying to find the area of triangle ADE. AC is that whole side, that's 9. And then AE will be 5. So if I'm going to find the area of ADE, I'm going to cross multiply, like I did last time. Cross multiply, and then divide. So it's going to be 135 times 25 divided by 81. And when I do that, the area of triangle ADE is 41.67 meters squared. So there's my area. The second part of the question says solve for y. Okay, so to solve for y here, I now know those two areas. So I know the area of triangle ABC and the area of triangle ADE. And this time, because I'm trying to find y, I'm going to use the 3.2 with that. So I'm going to use, that side is BC, so this is going to be BC squared here. And this one will be DE squared here. Okay, so I'll plug in my values. I know that the area of ABC was 135. And I just found the area of ADE is 41.67. BC is y, so that's like y squared. And DE is 3.2 squared. So y squared is going to equal cross multiply and then divide. So it's going to be 135 times, and 3.2 squared is going to be 10.24 divided by 41.67. And for my last step, because this is y squared, I have to take the square root of that answer. And when I do that, I get 5.8. So 5.8 units is the length of part Y. Okay, that's great. We'll see you tomorrow and we'll do some practice questions on this stuff.